This is probably obvious, but generally the idea behind the tool is that the time spent making it makes up for the time lost by not having it. At least that's what one hopes for. Sometimes though, it's easy to get carried away with the small details. Whether adding cool, extra functionality, or just making everything look as nice as possible. I'm guilty of both. Last time, I started on this vise mountable rotary fixture plate. While I made some pretty good headway on the build, I didn't quite get it to a usable form, and a tool I can't use doesn't do me any good. So today I pick up where I left off and finish the last few pieces to get this thing operational. And who knows, maybe even make something with it. I've got the top plate and spindle knocked out, as well as the base plate and all the bushings that let this thing spin smooth as butter. But I still need the piece that holds it all together, the locking collar. This is basically just a threaded ring, but to hold it in place I went with one of my favorite mechanisms, the split clamp. And I've got an offcut of A2 tool steel on hand that will work perfectly for this. I'll start on the lathe, first facing away the hints of whatever project this was previously used for. Then move on to the outside, turning it to diameter. Now for the inside. The collar will only be half an inch thick, but I'm drilling out the bore closer to 1 inch deep so that I'll have some breathing room for the cuts to come. Starting with the boring bar. I need to finish out the ID to a suitable starting point for the threads. And while I'm in here, I'll also go ahead and turn the front relief detail from my design. Now I could of course run a tap through here and be done with it, but that doesn't necessarily guarantee the threads will be square to the front face of the collar, and they need to be in order to evenly load the bushings on my assembly. So instead, I'm going to single point turn these threads. Only my usual cutter is a smidge too big for the bore. Luckily, designer Brandon realized this ahead of time and bought machinist Brandon a smaller tool for the task. How considerate of him. I'll get this mounted in a holder, then set the height using my trusty tool height indicator. Now here is a tool that's fast on its way to a decent return on investment. Anyway, before I go cutting threads, I do have one more cut to make. And that's to open up the bore at the bottom of this hole. This gives me a clear run-out area for the thread cutter where I'll disengage the thread feed between passes. I'll get the feed set up on the gearbox, then as a personal preference, I like to use the compound slide for adjusting the cut depth. Because this is an inside job, I'll position the slide 60 degrees towards the spindle rather than away. This ensures that the cutting forces are pushing to the correct side of the backlash in the compound's lead screw, which will make for a better cut. Alright, let's do this thing. The stem on this cutter is relatively small, so I'm keeping the cuts light at about 5 thou per pass. And to check the progress, I'll use the threads I already cut on the mating pivot shaft. Though in hindsight, maybe I should have waited to press this pin in place. This thing is a handful. At any rate, a couple passes later and the collar is a perfect fit. To finish this off, I'll start the parting cut, but before going all the way through, I'll switch to a chamfer cutter to clean up all the edges. Then back to the parting blade to finish the job. I'm not too pleased with how that came out though, so I'm going to go ahead and remount this, use a dial indicator to true up the ring, and then pretty up this side as well. Coming along nicely. Let's switch machines and finish this part out. Over on the mill, I'll get this clamped on the vise face up using a couple V-blocks. Then use a coaxial indicator to align the spindle on the collar center line. From here, I'll pop 2 spanner holes in the face, and of course give them a little kiss from the chamfering bit. To work on the last features, I'll need to change orientations. I can clamp this in the end of the vise, but I need a way to position it at the right angle relative to the 2 holes I just drilled. So why not use those holes for the alignment itself? A couple of drill shanks inserted and then pressed against the side of the vise should get this pretty darn close. And of course the other side of the vise is balanced with a similar thickness bar to ensure my part doesn't come loose. After using the edge finder to locate the part, I'll start on the hole features. Beginning with the counter bore, then the clearance and tap holes, and finishing with the threads. This leaves one last easy task of cutting the clamping slit. I just need to swap the blade on the slitting saw real quick. Oh no. Okay, well it seems this honkin' saw blade I used last over-tightened the screw to the point that it won't budge. I even bent an Allen wrench trying. Looks like I'm going to have to do a little side project before I can finish this part. Back in action. Though this poor arbor has been taking quite a beating since I first made it. I guess it adds character, right? Anyway, I'll get a thinner slitting saw blade on here, remount the locking collar, then bring the saw in to finish it out. Alright, let's see how it works. That is pretty much perfect. I'll need to adjust the tightness later on when I have everything mounted and can get a better feel for it. And to do that, I'm going to need the vise mounting block. So that's next. The first step of almost every milling project is getting the stock square and to size. Working through each side in sequence, mounting, cutting, measuring, remounting, and so on. And honestly, this makes me want to pull my hair out. So I'm going to do something a little more follicle friendly and attempt to do most of the squaring and other operations in a single setup. I've got an aluminum blank here that's about 1/8 of an inch larger in all directions than my final part. So I'll clamp it by a small sliver at the bottom and we can begin. First up is skimming the top face flat. A perfect job for this massive fly cutter. I made this bad boy for a specific job a while back, but I've been pleasantly surprised how often I find myself using it. Seems like every time I turn around, there's some wide surface that needs to be decked flat, and this makes doing that in a single pass a breeze. Like all fly cutters though, it does make a bit of a mess. But a cleverly positioned trash can make a big difference. But honestly, that's just a tiny price to pay for the beautiful surface finish this thing leaves in its wake. Okay, that's side 1 of 6 trued up, now for the next 4. I'll get a clean 4-flute end mill mounted, bring it down to just above the vise jaws, and start my way around the 4 sides. First the front, then the right, and finishing the loop with the back and the left. Then I'll just keep working my way around and around in this fashion until I'm down to my 4x4 inch dimension. Look at that, 5 sides squared into size and I didn't even have to move the part once. Even better, I'm already indicated in on the part, so I can move right on to popping all the holes in here as well. I'll start by spot drilling the 7 locations, then drop in the clearance holes for the 4 corner bolts. These are counterbored with an end mill to hide the bolt heads, and another peck from the chamfer bit cleans up the edges. Next I'll draw out the center bore with the largest drill I have at my disposal. But this hole still has quite a ways to go to make room for the locking collar in the assembly. So this is where the project gets kind of boring. I'm going to let the machine do the work on this one, so I'll set up the quill feed for an easy 2 thou per rev, turn on the spindle, and let her rip. With each pass, I'm opening up the bore about 1/10 of an inch to quickly get in the neighborhood of the final diameter. This does create quite an annoying rat's nest with each cut though. Fortunately, the final 10 thou pass is a lot less contentious and leaves a beautiful finish on its way through. Perfect. I'll give this a quick deburring, then might as well take advantage of this setup for one last but very critical operation. Alright, that one setup let me knock out about 90% of the part, and despite only being secured by about 1/8 of an inch material, it seemed to hold just fine. I may need to use this approach more often. To finish this one out, I'll flip it over in the vise, then bring in the heavy artillery one last time to quickly skim that remaining material off the bottom and take it to thickness. I also can't forget the access hole from the side. Without this, I'd have no way of tightening the locking collar. And since I'm here, I might as well get these edges too. Let's see how everything fits. Bolt holes line up, which is a good start, and access to the locking screw is pretty easy. The real question though is how centered is it? I'd say it doesn't get much better than that. I didn't leave much free play on those screw holes, so I must have drilled them bang on. At any rate, I will go ahead and pin these together so nothing shifts. I did already spot drill for these holes in the bottom, but I realize this will be a heck of a lot easier to do from the top. So I'll use the coax indicator once again to find the center of the assembly, then move on to drilling and reaming the two holes. It would be nice to be able to get these two apart though, so I'm reaming the top plate as a clearance for the pins, while using a slightly smaller reamer through the bottom plate, making it a press fit. Alright, with those two parts knocked out, I've got myself an assembly that will not only hold itself together, but is also mountable in the vise. So tune in next time where I'll work on the rest of the hardware. I'm just kidding. Let's make the handle for this thing. Every handle needs a knob, and every knob needs knurling, so I'll start here. This glorious brass bar is already at the diameter I need, so I can just send the knurling tool on its way. That ought to do nicely. I'll get this end cleaned up real quick, then I can move on to something a little more interesting. I have a 15-degree taper to cut on the end, and I also want this sort of chamfer type deal to be at 30 degrees. So I'll get the lathe set up to do both at the same time. First adjusting the 15 degree with a compound slide, then setting the tool edge at 30 degrees with an angle block. I'll get the tip center roughly zeroed on the end, then mark my stopping point and start cutting the taper. I don't know about you, but I could do this for hours. After checking the progress, one last pass takes me to the final diameter, and from here things get a little more familiar. First tap drilling for the threads I'll need, then drilling out a portion for the stem handle and reaming it to size, and finally coming back and tapping the threads. I still have some more shaping to do on this knob, but this is all I can do for now. So I'll part this off and begin on the other piece of this handle, the stem that this knob mounts to. I had this A2 rod on hand that will be perfect for the job. It is a tad oversized from what I need though, so I have a little work ahead of me. After preparing the end for a live center, I can bring out the full length and get to work. I've got about a 1/4 inch to remove off this diameter, and my normal approach would be to start with some heavy passes, then gradually get lighter and lighter until I reach my final dimension. But I've been finding that lighter passes don't always leave a nice finish. Heavier cuts do come out a lot nicer, however the higher cutting forces involved can actually deflect the stock furthest from the chuck, causing a taper in the shaft. I need to find a happy medium between the two. So after playing around with different depths, I settled on a 10th thou depth of cut. Now I just have to work it out so that my final pass is a 10th thou cut, which gives me a perfect finish and an accurate diameter. With the body of the stem out of the way, I can work on the ends. The first is threaded with a 45-degree taper to match the countersink in the top plate. So once again, I'll set this compound to this angle, then adjust the cutter angle as well, and start working on the end. First, turning down the major diameter of the threads, then using the compound slide to cut the taper and thread runout, and lastly, switching gears to knock out the threads. Let's see how that fits. Pretty freaking solid. Alright, let's finish up the other end. This is pretty much the same as the first, except it doesn't have the taper. I also didn't bother shortening this stock to the length of my drawing. I figured the extra leverage wouldn't hurt, and probably would have resulted in an offcut that never got used anyway. With the stem complete, I can attach the knob with some Loctite and finally finish it out as well. First facing the end to length, then dropping a nice honkin' meaty delicious chamfer on the end. Man, this thing has some weight to it. I'm not one for clubbing baby seals, but I think this would fit the bill. It should also do just fine for what I need on this fixture plate. But there's just one more thing I can't resist adding. Some scallops. I'll get this mounted in a collet block in the vise, double check its verticalness with a square, find the center with the coax, then work my way around with an end mill to cut the features. Man, does this thing look nice. And the addition of the scallops really took the grippiness to a whole other level. Which is just what I need for screwing this handle in place. There needs to be no free play whatsoever because obviously a loose handle is super lame, but also because the handle doubles as part of the hard stop mechanism. Which leads me to the next part of this build, the adjustable hard stop mounts. This is essentially another split clamp, surprise surprise, where one screw acts as the adjustable hard stop, and another screw locks the first one in place while also securing it to the base plate. Critical to that attachment being stable though is this V-groove, which requires a similarly complex curved and angled feature on the hard stop. And less critical are some fillets and rounds, because. This may all seem needlessly complicated, but it makes my brain wiggle, so I'm going to go for it. Oh, and did I mention I'm making 2 of these? I've definitely got my work cut out for me. But if I'm smart with my setups, I should be able to knock out both almost as fast as just one. To start, I'll square up a block large enough to make both parts from. And to make quick work of this, I'll use that squaring method from before to knock out 5 of the 6 sides. Now I can jump right into the actual features. I'll start with the clearance holes for the mounting screws, which of course each get a little dip from the chamfering bit. Dip, really? Then I can jump into milling out the shape of these things. First removing most of the material from either side that forms the tongues. Then I'll bring the mill down as far as possible without touching the vise jaws and cut the rest of the profile to form the fillets in the corner. With most of the material removed, I'll take one last skim pass both high and low, taking the tongues to dimension. So far this is coming along great. Or is it? Turns out I cranked the mill the wrong way a couple thou and put a nice divot where I definitely didn't want any divots. I won't lie, I'm very tempted to feed this to the box of shame. It's been looking rather hungry lately. But since I'm also not super sure how well this mechanism is going to work in the end, I think I'll keep going, fix any other bugs that pop up, and remake it later on if it's really bothering me. No snack for you today, buddy. Mounted back in the vise, I'll remove the rest of the material from the bottom, taking this to thickness, then turn it on its side, and drill and tap the holes on either end for the adjusting screws. Alright, that takes care of the square stuff. Time to turn it up a notch. Which means I need the rotary table. But hopefully this is the last time I'll have to set this up for a while. Shh, nobody tell it what I'm really working on. I fortunately already have a centering plug for locating the part on one of the through holes. So I'll use a square to get this close to straight, drop some step clamps on here, then tram the part in more accurately with an indicator. I'll also go ahead and remove the excess material from the middle that will just be getting in the way. Okay, after all that setup, I can finally actually cut the rounds on here. I'll sweep the table back and forth 180 degrees and bring the mill in just shy of where the measurements say it should be tangent with the part. This should prevent overcutting, which would result in more of those beautiful divots in the part. At least in theory, that is. Why on earth did that happen? Well, it looks like somehow the holes I drilled aren't actually centered on the part. They're a couple thou to one side. Not sure how that happened. This won't affect the functionality of the part though, just the locations of these rounds. And I should be able to clean up this little boo-boo later on, so I'll keep going. The second round goes much the same, except I stopped even shorter this time to prevent any more divots. The first 2 rounds taken care of, I can make a quick trip back to the vise to remove the rest of the material off the backs of the tongues. Now for the 2 rounds on the adjustment screw ends. Though these would be a bit tricky to both center and support on the rotary table. So I'll take a bit of a shortcut and just use the belt grinder for these 2. After grinding those down and doing the final touches by hand, I'm nearing the end of these parts. I've done as much as I can with the two connected, so I'll cut this in half on the bandsaw. Then set these up in the mill vise and clean up the bottoms to take them to size. Alright, just a couple more cuts and these parts are finished. And while the end is near, I'm more excited because I saved the best operations for last. These stops mount on the V-groove on the base plate perimeter. And to ensure they make a solid connection, I have to cut a matching curved V-shape on the face of the part. This should be good. I'm not exactly sure how I'll go about this though, all I know is I'll need the rotary table. So hang tight while I mess around a bit and see what I can come up with. Okay, I'm feeling really good about this. What I've got here is basically a nesting fixture that will hold the parts both square, centered, and at the correct distance from the rotary table's axis. But what's really neat about this is that it will hold the part both right side up and upside down. A couple of socket head cap screws on opposite corners hold everything tight, and to cut the angled faces, I treated myself a little and bought a solid carbide chamfering mill. So let's see if all this is going to work. So far so good. Bringing the cutter in about 10th thou with each sweep of the rotary table seems to be doing well not to yeet my part from the fixture, which is a good start. I also already did the math ahead of time to know exactly how far off center to bring the cutter to produce the arc I need. This is pretty important for the clamp to saddle correctly in the V-groove of the base plate. I'm not actually matching the arcs exactly, but rather making this one about 10th thou smaller on the radius. This should cause the outsides to engage in the groove first. Then as the mounting screw is tightened, the slight amount of compliance in the material should keep things seated very securely. After cutting the angled faces on both sides of each of the stops, I'll switch to a regular end mill to relieve the material from the middles as well. Let's see how they fit. That is very confidence inspiring. It basically falls right into the groove and doesn't wiggle so much as a hair. Just a couple more things and these are done. I'll get these set up in the vise to mill the sides the rest of the way down the width. Then finally switch to the slitting saw to cut the adjustment screw clamping slit. After a little more cleanup on the emery board, I'm not too upset about the little boo-boos I made earlier. They've mostly disappeared, or are small enough that they aren't really noticeable. Which is good because these are a hell of a lot of work, and I'd rather not remake them for something so small. But now it's time for the moment of truth. Will the stops both secure themselves with the base plate and lock the adjustment screws? Well, it definitely isn't going anywhere. But while it does get tighter on the adjustment screw, it's not as snug as I would like. And the clamping slit is already closed all the way, so it's not getting tighter. A wider slit probably would have been better, but trying to run a thicker blade through the slit now doesn't sound like a wise idea. I think I know what I can do though. I'll get this remounted on the mill, then bring the slitting saw back in to cut away just a little on the opposite side of the threaded hole. This should give the slit just a little more flex to close up on the threads a bit more. Now that's a huge improvement. Pretty cool how such a small change can make such a big impact. Even better, the dimensions all worked out great, so these line up perfectly with the handle stem. Which means I've pretty much got this thing wrapped up. What do you say we get this thing dialed in and take it for a test drive? The whole idea behind these stops is that I want to have a repeatable starting and stopping point as I swing it through its arc. For instance, 0 to 180 degrees. I can use the straight edge of the dovetail groove to tram the top plate in using the adjusting screw, and once there, tighten the hard stop, which also locks the adjustments. Then I can swing it around and do the same for the opposite side. Now I can easily and repeatably make 180-degree rounds. But what if I only want to round a 90-degree corner? Then I'd have to adjust all the hard stops again, right? Wrong. When I made the handle a little bit ago, I also made this. It's basically a mini version of the handle stem with the same taper and threads. So I can pop this in a perimeter hole 90 degrees from the main handle, and viola, 90-degree sweeps. If I did everything right, this should read trammed as well. Which it does. Nice. Alright, enough blathering on about the features. Let's see this thing in action. I'll first need to find the table center with the coax, just like I did on the big rotary table. I also whipped up a small selection of centering pins that pop down in this bore. I'll drop one of these in here, then some spacer material, and then the test part. And lastly, a couple of these stylish hold-down clamps I made not too long ago. This does leave the last issue of squaring the part. I know how far in I'll need to bring the end mill when I make the cut. So if I come in that distance, then scoot over a bit off center, I can rotate the part around until it bumps the end mill and then lock it all down. And now, finally, a test cut. This is amazing. Everything just pivots so smoothly, and I don't have to worry at all about overshooting on the ends. Man, this is nice. How about a 180? Even at this larger radius, this is no problem. It doesn't even remotely feel like it's getting away from me. But at the same time, it's very easy to feel what's going on with the cut and whether I'm pushing too fast or too slow. I'm really liking this. And I'm definitely looking forward to making some real parts on this bad boy. But this does beg the question, what about parts that don't have corner holes? Well, you see, there's still even more to this build. I know, this is really getting out of hand. I've got an idea in mind that involves these dovetail slots. I have no idea if it's going to work or not, but if all my brain noodling pays off, it's going to make this super nice tool even cooler and easier to use. So until then, and as always, thanks for watching, and see you next time.